At this point in the lesson, we have our tree defined, we have some movement defined, so the tree is going to move left and right. We also have some erratic movement defined. So at this point, we want to start setting up the spawning of our apples. We want to spawn apples from the apple tree. Okay, so as your tree moves along, it will spawn apples that we can catch with a basket, which we will set up and define in upcoming sections. To get started, I want to declare a variable which will keep track of the seconds between the instantiation, or that is the spawning of the apples. Following this, we will set up a timer just like we did with the change direction timer, which will call a spawn function every time frame as per the variable which we will set up here. So what I'll do is I'll just go ahead and copy a float. That is just to save some time. This is a long identifier, you can call it something else, but this makes it obvious to see what this actually is. Copy that. In the constructor, I want to go ahead and define that. In the constructor of the tree base, I will initialize this to 1. Jump back over to the treebase.h. Declare a timer handle, apple spawn timer. You can call that what you want, of course, and then the associated function, which will be spawn apple, which I will right click, quick actions and refactoring, create the definition of that. Jump over to that. Now, while this project is quite specific, you may also want to think about how we can change this to be more generic. It is often the case that you want to change your theme later on as you go through and develop your game. In other words, the theme of your game might change later on. For example, instead of a tree that spawns apples, you may have an alien ship that drops bombs that you have to catch or smash. So this project is quite specific, but when you go ahead and start building out and prototyping your own ideas, do keep that sort of flexibility in mind just in case you decide to change your theme later on. I will go ahead and set the timer in the begin play. So here where we do get world, I will copy that and I will set the timer. We want to use the apple spawn timer for this. And we will change the function that gets invoked as well. We want to spawn an apple. And then we have this long variable here that I mentioned that we set up seconds between apple drops. Instead of redirect time, I will use seconds between apple drops. For every seconds between apple drops, go ahead and invoke this function, right? I will also go ahead and modify the initial timer to 2 seconds. Next, we need to think about what we want to do in the spawn apple function. So if you think about it, we basically want to spawn apples randomly to the left or to the right of the apple tree with some offset. Instead of at the center of the apple tree, that is, instead of spawning in the same place each time at the center of the apple tree, we want to add some randomness and some unpredictability and interest to the game. And to do that, how will we go about doing that? We have to get the treebase current location. So an instance of treebase, of course, our apple tree. We get the current location. This is basically what we want to do in the spawn apple function. We want to get the treebase current location. Then we want to add an offset randomly to the left or to the right of the current location. And then we want to spawn an apple at that new offset location. Because again, we don't want the apple to spawn at the center of the apple tree at its current location. That's a bit boring. We want to add some more randomness and interest to the game. So as an exercise, go ahead and try implementing this by yourself. Give that a try, and when I come back, I will show you my implementation. You have different versions of the spawn function. I will use one where we can pass in the spawn location and the spawn rotation, for example. Again, based on the version of the spawn function that I want to invoke, I'm going to use the location and the rotation of the actor. Next, we want to do a check, so we want to do an offset randomly to the left or to the right of the current location. So what is this check going to be? Well, we talked about the if math previously. Again, we're only going to spawn to the left or to the right of the apple tree randomly. So 50-50 basically for the checks. We'll do a quick check. In this case, I don't see it is necessary for us to go ahead and create a variable to pass in here. So I'll just use a literal float instead. In this way, we're going to do a slight offset from the actor's current location, and then we want to spawn the apple at the new offset location. You have to think for a second, what is it that we actually want to spawn in here? Well, we want to spawn an apple, right? So we have to go ahead and include that, because if you write out a apple base, the identifier a apple base is undefined. So we have to go and include that. You can include applebase.h and that should work fine. I'll just scroll back down. Typically, if you click somewhere, IntelliSense will update and you can see it has updated. Also, if that does not work for you, what I prefer to do is, I prefer to specify the full path. For example, under Apple Picker, we have our source file, we have the Apple Picker folder, and that is basically where all of our source lives for this particular project. So what you can do is, you can specify the full path. If you had a longer path, so for example, you go ahead and you split the files up into public and private, and you split them up into different folders, such as actors, for example, then you'll have Apple Picker /public /actors /applebase.h. Alright, since we did not go ahead and do that in this project, for this project, we kept it simple for this project, we can simply go ahead and include this. But as I mentioned, only including applebase.h should work perfectly fine as well. Now we have a different thing to think about here. What arguments are we going to provide this? Well, it would be nice if we could go ahead and allow the artist or the designer to specify in the blueprint exactly what apple to spawn. Go back to the header here. I will use the subclass of instead of a regular raw pointer. I will specify the type here, a apple base. I will call this spawn object, the type of object that we want to spawn basically. And with this, the designer can now go ahead and select the specific apple that they want to spawn from the apple tree. So again, this allows us to specify the specific actor in the editor. Now you can also go ahead and forward declare a apple base, for example. And that is now forward declared, so we should not have any issues with this code here. It did show up in the IntelliSense, but I'm just making sure, so I will forward declare the apple base class at the top here. And that should be about it. Copy that and I will pass that in for the first argument. For the second argument, we want to pass in the location where we want that apple to spawn at. And that is what we have calculated in the rest of the function. And also spawn rotation. This also allows you the flexibility to think ahead in terms of what you want to do. Maybe you want to modify the theme long term, as I mentioned in a previous subsection. This allows you some flexibility to maybe modify the rotation and stuff like that. This should be all that we need for right now, so go ahead and build around that. That succeeded, and we'll now run the editor. Back in the editor, we'll open up the tree blueprint. And then in the setup section, we can now go and specify exactly what object we want to spawn. In this case, we want to spawn the apple blueprint because that has already been set up with the static mesh and everything like that. Select that. Compile and save. Let's see what happens. Simulate. And that will now start spawning apples. If they do not fall down, stop this. Open up the apple blueprint. If the simulate physics is not enabled, so down here simulate physics, if that is unchecked, alright, compile and save that. If I simulate now, you will see that those apples will not fall down. Because of that, I want to enable we need to enable simulate physics. We need to set that to true and compile and save. Save my level and everything and simulate. We now get those apples spawning to the left and to the right of the tree randomly. You can go ahead and make changes to the offset if you want. And that is going to conclude this setup of the spawning of our apples. We will continue right on in the next lecture.